Welcome to this overview of DynamicNLP, Yellow AI's proprietary technology. It is first in the enterprise conversational AI market to eliminate the need for training natural language processing models. Let us first look at the current industry trends when it comes to building intelligent chatbots. The entire process of training an NLP model is a repetitive and manual effort. For training the bot on data for every business use case, we need to think ahead of time on the various utterances that can be input by the users with relevance to a particular intent. These utterances need to be mapped to an intent to prepare a training model. This is a continuous iterative process rather than a one-time effort. The conversations are continuously monitored after going live with the initial training data. We then find and extract relevant user inputs that were not used to train the bot initially. These real-time data are then added to the training model to improve the bot. The more the iterations, the better trained our bot will be. This repetitive and time-consuming process can sometimes take several weeks before we see significant improvement in bot accuracy. To add to these problems, our live bot will not play an effective role in handling user queries in real time. This leads to a bad user experience. These worries will now be a thing of the past with Yellow AI's DynamicNLP. This breakthrough technology is designed to significantly minimize the time taken for your business to go live in the market by several weeks and automate conversations with the top-notch accuracy. DynamicNLP is built on a cutting-edge concept called zero-shot learning. This concept eliminates the lengthy process of manually labeling data for training chatbots, which completely changes the game for enterprises. The NLP engine comes with a pre-trained model and unsupervised learning that works right out of the box. This model makes it easier for enterprises to deploy dynamic agents instead of traditional chatbots. In the following demo, we are going to look at the difference in the training process of a traditional chatbot compared to a chatbot developed using the DynamicNLP model. For a traditional chatbot, we add intents for all business use cases and then map a certain number of utterances to each intent. This would be the key to effective training of the chatbots. The perceived intelligence of your chatbot would be directly related to the quality of the training data. On clicking the Train button, the NLP engine in the backend would consume the utterances provided for an intent and learn how to detect these in a user input in real time. This ultimately gives the confidence for your chatbot in mapping a user input to an intent. The confidence score would depend on how closely the user input matches the training data. Higher the variations, lower will be the confidence. This is the reason that the training data needs to be as exhaustive as possible. Let us train a traditional chatbot now and try conversing with it. We are going to add an intent and an utterance that maps to the user's input to apply for a car loan. Let us train the bot on this intent. Now, let us create a flow in the Builder section that would be triggered by this intent. This flow would represent a conversation that should help the user apply for a car loan, which can include various messages and actions. It should be triggered when the corresponding intent is detected by the bot. For now, let us add a text message to highlight when the flow gets triggered. Let us converse with this bot and use the exact utterance that was used in the training process. As expected, the bot detects the intent and triggers the flow to which it is mapped. Now, if we try simple variations to the utterance, the chatbot will still detect the intent and work as expected. However, this will not be the scenario when your chatbot goes live and faces different kinds of users. The variations in the user input would range from changes in wordings, sentence structures, spelling variations, among others. As long as the intent is clear, we would like our chatbot to detect it. Let us try bringing in significant variations in this chat. The chatbot fails to understand this input, though it looks relevant to the car loan application intent. This is the case for all the different possibilities in the user input if the words present in it were not used as training data. Let us use the failed utterance and map it to the intent that we created in the NLU section. We can then retrain the chatbot. Once the training is complete, we can input the same utterance. Now we see that the chatbot is able to recognize the underlying intent and trigger the mapped flow. This is the fundamental problem with a traditional NLP engine. The steps taken to minimize these failures include activities that are performed before and after going live. Before going live with the bot, we need to spend time and effort in generating an accurate and exhaustive training data. After going live, we need to monitor the bot's conversation in real time. We then need to analyze them to determine how the training data can be improved. The complexity in this approach grows exponentially when you add other intents for covering all your use cases. In this case, we also need to ensure that there are no conflicts in utterances mapped to 2 or more intents. The whole training process is a lot easier with the DynamicNLP engine. Let us now use another chatbot build on the DynamicNLP engine. We will add the same intent and utterance that we initially added in the traditional chatbot. We can train the bot and then map the intent to a flow. Let us try conversing with this bot. First, let us use the same utterance that was added to the training data. As expected, the bot detects the intent here. A few simple variations to the utterance will work as well. So far, this chatbot is as efficient as the traditional one. Now, let us try the utterances with significant variations that failed in the traditional chatbot. We can see that the chatbot now detects the underlying intent for all possible variations that one can expect in an utterance. We have completely minimized the training data here and kept it simple by adding the intent alone. No time or effort was spent in preparing an exhaustive training data to train the chatbot like we did in the traditional model. Let us now see how the DynamicNLP engine handles ambiguous inputs. We will create another intent in this chatbot and make it sound similar to the existing intent. We can train the bot and then map the newly created intent to a different flow. So now, we have 2 intents and 2 corresponding flows, one for a car loan and another for a bike loan. The type of vehicle is the differentiating factor between the 2 intents. If a user now gives an input that only mentions the word loan, the ambiguous nature of the intent is detected as there might be more than one intent matching the user input. The chatbot responds to the user with all the detected intents as suggestions. Once the user confirms their intent, the corresponding flow is triggered. Note that the other intent present in the NLU section is irrelevant to the use case and is not displayed as a suggestion. This is a smart and robust fallback mechanism for your bot to handle various cases of ambiguity arising through user inputs. And for the user, this leads to a much enhanced conversational experience. With the power of DynamicNLP at hand, all that we need to do now is create the required intents on the bot, train it, and go live. The DynamicNLP is highly effective because it is trained with billions of real-world conversations and is trained to handle all kinds of users and their variations right from the word go. On receiving a user input, the engine performs an unsupervised search and tries to find the closest match to one of the intents added to the bot. Once the intent is detected, the corresponding flow can be triggered. By analyzing billions of conversation data that occurred in the past, DynamicNLP can now solve problems of the future across industries by helping you accelerate your intelligent business automation journey. Thanks for watching.